Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about our PBL, the straightforward problem-based learning project for our course Engineering Mathematics DAM13303. Alright, we are from group 3. Let me introduce my group members. Firstly, my name is Sukma Arifin bin Anwar. My metric number is AA220470.
Hi and Assalamualaikum. My name is Muhammad Adam Abdullah and my number matrix is AA221432.
Assalamualaikum. My name is Izul Hafiz bin Mas Azri and my number matrix is AA221156.
Assalamualaikum and good afternoon. My name is Muhammad Azrul Azam bin Riza Remi. My metric numbers is AA220C82.
Assalamualaikum. My name is Muhammad Khairin bin Abdul Muhammad. My matrix number is AA221616.
Alright, today I would like to talk about introduction. First, application of first order ordinary differential equation ODE. Usually used in multiple fields like physics, engineering, economic, engineering, biology and others. First, these equations are used to model growth and decay phenomena, describe the motion of objects under external force, analyze electrical circuits, study chemical reactions and kinetic reactions, and understand economic dynamics. The application of first order ODE extends to various engineering disciplines. In mechanical engineering, ODE are crucial for analyzing systems involving such as fluid flow, heat transfer and structural dynamics. ODE also help engineers understanding behavior of fluid mechanics, design efficient heat exchangers and model the vibration and response of mechanical structures. Overall, the application of first order ODE in engineering is instrumental in solving complex problems, optimizing designs, and ensuring the reliable operation of various systems.
Alright, now is my part. Part A for question 3. A small population of small city had 300,000 people in the year 2000 and has grown at a rate proportional to its size. In the year 2005, the population was 400,000. The question A, find an expression for the number of people in the city D after the year 2000. The question B, estimate the population of the city in the year 2010. And the last question C, assuming the growth continues at the same rate, when will the town have 1 million pupils? Now I will continue for the filler table for part A for the previous question. Filler stand for fact, ideas, learning issues, and action plan. First, we're looking at facts. Here we have give 3 facts. First, a population of a small city had 300,000 people in the year 2000. In the year 2005, the population was increased to 400,000. And number 3, grown at a rate proportional to its size. For the ideas, here we give 4 ideas for the reason. 1. Migration of new residents. Number 2. Population spread. Number 3. Industrial area development. And number 4. Tourist attraction area. Next, learning issue. Why did they move to the area? And number 2, what factor caused the area to become the focus of industrial construction? And number 3, what are the country's attraction? And for the last part, action plan. Here we give 3. Number 1, build a continuous net. Number 2, finding sources from journal. And the last, number 3, explore resources from the internet.
Here we come to the solution of part A. Using the exponential growth and decay formula, that is Pt equal to P e to the power of Kt, we need to understand the meaning behind this formula. Pt is the population at the time, where P is the initial population, E is the exponent, K is the constant growth, and T is the amount of time. Based on the question that we looked earlier, we know that the 300,000 people is the initial population, where 400,000 people is the PT, and the amount of time is the gap between year 2000 and year 2005, that is 5 years. Now, based on the information that we got, we can put it into the formula. Now the equation that we got is 400,000 people equal to 300,000 people multiplied by e to the power of k5. Now we need to divide the 400,000 people with 300,000 people, making it, the answer is 1.33. Now the equation that we got is e to the power of k 5k equal to 1.33. Now to make it the k left alone, we need to move the exponent to the right side. Now the equation that we got is 5k equal to ln multiplied by 1.33. Then the answer we got is 5k equal to 0.2874. After that, we need to divide 0.2874 with 5, and the answer will be 0.0575. Now the final answer is PT equal to 300,000 people multiplied by e to the power of 0.0575 t. That's it. Next is question B, where this question is relatively simple, where we need to find the population in year 2010. Based on the question, we know that the amount of time is 10 years, so that we can put it into the formula. Now the equation will be P10 equal to 300,000 people multiplied by e to the power of 0.0575 multiplied by 10. After we solve all the equation, the final answer will be P10 equal to 533,136.16 people. That's it. Here we come to the final question, that is question C, where we need to find the time when the population will reach at 1 million. Using the same formula, we know that PT is 1 million, where P is 300,000 people, and K is 0.0575, and T is the answer that we need to find. Now the equation will be 1 million equal to 300,000 people multiplied by e to the power of 0.0575 multiplied by t. Now we need to divide the 1 million with 300,000 people, making the answer is 3.333. Now the equation will be e to the power of 0.0575 multiplied by t equal to 3.333. Now to make it the t sit alone, we need to move the exponent to the right side. So the equation will be 0.0575 multiplied by t is equal to ln multiplied by 3.833. Now we need to solve the equation, and the equation will be 0.0575 multiplied by t is equal to 1.204. And we need to make the t sit alone, so we need to divide 1.204 with 0.0575, and the final answer will be T is equal to 20.939, is the around 21 years is the final answer. So the final answer it will be year 2021, where the population will reach at 1 million. That's it. Thank you.
Okay, so for the part B, question 3. During the holiday season, you help your auntie with her catering business. Before you can serve soap to the guests, your auntie asks you to cool down the soap first. The rate at which a container of hot soap cools down is proportional at that instant to the room temperature. A container of hot soap is placed in a room temperature 18 Celsius and in 6 minutes. The solution cools from 82 Celsius to 50 Celsius. Determine the length of time taken, T, taken for the solution to cool from 30 Celsius to 20 Celsius. So for the question 2, let me explain in the filler table. Number 1, the task involves cooling down a container of hot soap. And second, the rate at which the soap cools down is proportional to the room temperature. And number 3, the room temperature is 18 Celsius. The internal temperature of the soap is 82 Celsius. And the lastly for facts is after 6 minutes, the soap's temperature has cooled to 50 Celsius. Second, others. The reason is cooling temp is affected by room temperature. Second, area exposed to ambient temperature. And lastly, type of container used. So, what is the learning issue? Learning issue is why don't people eat hot soap? And second, how long does it take for the temperature to drop? And how does the volume of the soap affect the cooling period? Action plan or resources need. Number 1 is build a questionnaire. Second is finding sources from journals. And lastly, explore resources from the internet.
So the solution of this question, which we need to find the time taken for solution cool from 30 degrees Celsius to 22 degrees Celsius. First of all, we need to know what formula that we need to use in this question. From the question given, the formula that we use is Newton's law of cooling formula, which the formula is Tt is equals to Ts plus in open bracket To minus Ts close bracket exponent to the power of negative Kt. The formula that we use, Tt is the temperature at that time, Ts is the surrounding temperature, To is the initial temperature, K is constant, and small t is time taken, and E is the exponent. So next is from the question given, we need to take out all the information that have been given in this question. The Tt temperature at the time of 6 minutes is 50 degrees Celsius. Surrounding temperature is 18 degrees Celsius. Initial temperature is 82 degrees Celsius, and the time taken is 6 minutes. For the information that we get, we just replace it in the formula of Newton's law of cooling. Then we get 50 is equals to 18 in a bracket, 82 minus 18 exponent to the power of negative k in the bracket, and the small t we replace it with 6. Next, we just calculate it as usual to find the constant of the object. We get 32 is equals to 64 exponent to the power of negative 6k. In this equation, we simplified first of all to get a small number, then we can easy to calculate it. after we simplify those number, we use log to eliminate the exponent, and the power we can take it as the basic number. Then we get that k constant of the object is 0.1155. Next, after we get the solution, after we get the constant value, we use it in the same formula with Newton's law of cooling formula. Tt is equals to Ts plus open bracket To minus Ts plus bracket exponent to the power of negative Kt. This time we need to find the time taken for solution cool from 30 degrees Celsius to 22 degrees Celsius. In the equation, the information that we get is the T, the temperature at the time is 22 Celsius. Surrounding temperature is 18 degrees Celsius. Initial temperature is 30 degrees Celsius, and the constant of this object is 0.1155. But we need to find the time taken. Then we just replace those information in the formula. We get 22 is equals to 18 plus open bracket 30 minus 18 plus bracket exponent to the power of negative 0.1155t. Then after we calculate as usual, we get 4 is equals to 12 exponent to the power of negative 0.1155t. Next, we simplify as this number, and we get 1 is equals to 3 exponent to the power of negative 0.1155t. Then we use ln to eliminate the exponent and to take down the power. After that, we get negative 1.0986 is equals to negative 0.1155t. Then we move negative 0.1155 to other sides and divide, and negative 1.0986 will be divided by negative 0.1155, and that t we get is equals to 9.51, which we change it in time. We get 9 minutes and 30 seconds. So the time taken that the solution goes from 30 to 22 Celsius is 9 minutes and 30 seconds. That's all from me. Thank you.
In conclusion, the application of first order ODE permits a wide range of fields. First, analyzing dynamic system, enabling researchers and practitioners to make predictions, optimize processes, and gain valuable insight. Unlock a deeper understanding of the world around us and make informed decisions to drive progress and innovation in various domains. That's all.